Okay, similar question as the last one. All right, what polynomial has -5 as a root and 3 plus I as a root? This one I'm going to make multiple choice just to start out, but I am going to go through and show you how you can do it without it being multiple choice because that's the way it is on your homework. But your test or quiz, it's going to be multiple choice more than likely. So I want to show you how you can do it. It's way easier if it's multiple choice. Okay. So if -5 is a root, that means that when you plug it in for x, you should get 0. And the same goes for 3 plus I. Right? If this is a root, then whenever I plug it in for x on here, I should get 0 out of the equation. And so that's what I'm going to do. I'm just going to take my answer choices, and I'm going to plug in -5 for x, and I'm going to plug in 3 plus I for x. Right? So if I do -5 store to x, and I try out option C, right, it's going to give me x to the third power 3x squared plus 50, and I do get 0. So this means that -5 is a root of this equation, but I also need 3 plus I to be a root as well. So let me try that. 3 plus I, and I'll store that to x, and I'm just going to type that in again. Reevaluate that. And you see I do not get 0 out of this, all right? Something non-zero. So that means C does not have 3 plus I as a root. I believe the answer for this one is B. All right, I've still got 3 plus I stored to x. If I try x cubed minus x squared minus 20x plus 50, yep, I get 0. And if I do -5 store to x, I will also get 0. All right, so this right here, B, is my solution. This is the polynomial that has -5 as a root. It has 3 plus I as a root, and because of that complex conjugate root theorem, 3 minus I is also going to be one of the roots. All right. Remember, these always have to come in pairs here. All right. The way you would figure this out by hand is going to be similar to last time. Like the setup is identical. All right. You figure out what your other complex root is, and then you're going to write it in factored form. But multiplying it out is going to be quite the chore. So the factors. If -5 is a solution, then x plus 5 is the factor that corresponds to that. If 3 plus I is a root, then x minus 3 plus I is a root. Now I'm wrapping it in parentheses because I want to do x minus that entire thing. And then I'll do the same for its conjugate. X minus 3 minus I. Okay. The way I suggest multiplying this all out is to multiply these two things, because when you multiply conjugates, all the imaginary stuff should go away, right? So I'm going to focus on these two first, x plus 5. The first thing I'm going to do is distribute my little negative on the inside. That's going to become x minus 3 minus I, because I'm distributing that negative to each one of those numbers. Same thing here. This will give me x minus 3 and a plus I. Okay. So when I multiply this, it's going to be really big. I'm going to multiply these two by each other. So I'm going to have 9 multiplications altogether, because I got to do this x times all 3 of those. And then I got to do the -3 times all 3 of them. All right, x times x is x squared. X times -3 is -3x. X times I is a positive ix. And now I'm going to do the -3 times each of these. -3 times x. -3 times -3 is positive 9. negative 3 times I, negative 3I. All right, and then I'm going to do this negative I times the rest of them. That's going to be negative IX. Negative I times negative 3 will be positive 3I. And then negative I times I will be negative I to the second power. So before I distribute this x plus 5, I'm going to clean up all this. There's going to be a lot of cancellation that happens. Like I said, all the imaginary stuff should go away. All right, positive ix cancels with negative ix. Negative 3I cancels with a positive 3I. And then this little bit right here, remember I squared is equal to negative 1. And so what you're doing is you are subtracting a negative 1. So this is like a plus 1 right here. If I write this out, it's going to be x plus 5. I have an x squared. I've got a negative 6x from these two, all right, negative 3x and negative 3x. And then these two, the negative 9 and the plus 1, that's going to make a positive 10. Okay, so all the imaginary stuff is gone. And then you'll have to distribute more, a lot more distribution. All right, x times x squared, x to the third. X and 6x will be negative 6x squared. X and 10 will be 10x. And then we'll distribute the 5 and x squared. 5 and the 6x will be 30x. 5 and the 10 will make 50. And then we'll combine like terms. X cubed. All right, I've got a negative 6x squared and a positive 5x squared. That'll be negative 1x squared. I got a positive 10x and a negative 30x. That'll be a negative 20x. And then there's the positive 50. And that's it. All right, if you check that out, it should match the answer option we had earlier for B. Yep. And we've already checked our solution basically. But yeah, if you want to check your answers, whatever answer you get at the end, just take these roots and plug them into the function, and you should get 0. All right, I believe that's it.